Good evening everyone. Today I'm going to explain the seventh experiment in the system.NET compiler lab. The seventh experiment is about predictive parser. The aim is to write a program in Java to parse a given string using non-recursive predictive parsing for a given grammar. This is the description. Recursive descent is a top-down parsing technique that constructs the parse tree in the top and the input is read from left to right. This uses procedures for every terminal and non-terminal activity. This parsing technique recursively passes the input to make parse tree, which may or may not require backtracking. But the grammar associated with it cannot avoid backtracking. A form of recursive descent parsing that does not require any backtracking is known as predictive parsing. This is the basic diagram of the parser. Coming to the code, I have been editing for this. I have given the name as a class name array star, which has protected character array, protected in top and south, public array star. Size is 20, array new array is initialized, top is initialized as management, public void push, the new method given the method push method here. If top plus 1 is greater than equal to size, then throw new index out of bounds exception. This is the overflow exception. If top plus 1 is less than size, array set is top equal to I. Public cat pop. This is another method for pop. This returns array, public void display. This is to display what you have given. For this, I have given for int I equal to top, I less than I greater than equal to 0, I minus 1, system out the array I. This gives the values that are stored in array I. Now I given a new class here. Class name parser, public starting void main string argument with exception. I given a new string array transition, new string array transition with new string with array length of 20 and 20. This is a multi-dimensional array. Int alpha set and state set are given here. This asks the user to enter the number of terminals where alpha set equal to integer dot parse br readline. System dot out of to enter the non-terminal. For this I given state set. The integer print integer dot parse br readline. System dot println. Please enter the string starting with non-terminal grammar. For this, cast state is br.readline to character array. System.println. Please enter all the terminals simultaneously. String alphabets equal to new string alpha set. So int I equal to 0 is alpha set. Here we print all the terminals simultaneously. This is the code for it. To enter all the non-terminals simultaneously, this is the code for it. Where I given for group int I equal to 0, I less than state set I plus plus, and this is for the array list. I created a new array list which stores all the non-terminals simultaneously, and system.println for epsilon use at the rate. To enter the row entries, this is a code for it, where the entire for loop I have given here, int I equal to 0, r alpha set r plus plus, string I equal to br dot result, transition, given two transition that is s and r, which is equal to int 1. For int s equal to 0, s less than state set s plus plus, for r equal to 0, alpha less than alpha set r plus plus. These are the two transitions. Now to give the input to the parser and to end the input with the $hash. This is to this we have given a array stack, new array stack. This is syntax for it. Stack dot push and stack dot push state of 0, int index equal to 0, stack input and output. These are three actions carrying on in this code here. Now we have to check whether the given string is accepted or not. For this, we have given cat3 input dot character index. string character 1 null and input dot char at index, int index equal to alphabet dot index char and string 2 equal to the null space. If this accept the condition, then it will the null value, or it will give the string which is not accepted. It breaks and goes into the next function. Here we'll check whether the parsing is completed successfully or not. For this character ch equal to stack dot pop, the character equal to cat3 index plus plus else if cat equal to runner stack push of ch. And ask the user whether to continue, we want to continue. So if he presses 1, he will continue, or 0 if he presses 0, then the process gets stopped. Scan is equal to new scan system.in, y equal to scanner.next, and while equal to y equal while y equal to 1. For this, I have already given the input here. See, this is the input, this is the transition table which we are giving into the parser as input. This has 6 rows for which we enter the values here. First it asks for the number of terminals. We give as 6, the number of non-terminals as 5, and the starting non-terminal in grammar is C. These are the terminals which we give simultaneously, and these are non-terminals which we give simultaneously. And these are the rows that we give into the transition table. These are 6 rows. This is the first row, this is the second row, this is the third row, fourth, fifth, and sixth. And our input will look like this in the table. And this is the output after we give the expression a plus a star of a dollar hash. This is the stack, this is the input, and this is the output. Here the parsing is completed successfully. And at the last it asks the user to continue whether to press 1 or 0. Here we return as 0, and this is the 7th experiment.